So here we are at section 132. This is continuous functions. No new theorems or rules for this set, but vocabulary terms. We do have continuous on an interval, and we have continuous function. So let's begin here. A function is said to be continuous on an interval if and only if it is continuous at every point in the interval. And then further, a continuous function is one that is continuous at every point on its domain. So a bit of a very subtle difference here. You can be continuous on some certain interval and not necessarily be a continuous function. But a continuous function is continuous at every single point in its domain, not just some smaller given interval. So a continuous function does not need to be continuous on every single interval. For example, the function 1 over x is not continuous over the interval from -1 to 1. And we'll see more about that very soon. But if we go from here to here, obviously that function is not continuous there right in the middle at x equals 0. More continuous functions. Well, polynomial functions are continuous because they're continuous at every single real number. Rational functions are continuous at every point in their domains, even though their domain might not be all real numbers. They have points of discontinuity where they have zeros in their denominator. The absolute value function is continuous at every real number. So are exponential functions, logarithmic functions, trigonometric functions, and radical functions. They're continuous, again, at every point in their domains, and all of these functions are considered continuous functions. They are continuous at every point in their domain. So here's another example. The reciprocal function we mentioned before, y equals 1 over x, is a continuous function because it is continuous at every point in its domain. However, it does have a point of discontinuity at x equals 0 because it is not defined there. Let's consider this curve. It is y equals 1 over x, and it appears something like this. And at x equals 0, there is a vertical asymptote. But the domain of this function is -infinity to 0 and 0 to infinity. And this function is continuous across that entire domain because x equals 0 is not in the domain. But we do have a discontinuity at x equals 0 because there is a vertical asymptote. So that would be an infinite discontinuity. And that's that.